Hello and welcome to, I think this is the last video of the section. So I did put chapter 3, section 3. I could be very wrong on that. I left that on there from last year. Anyways, this video is going to be very much partly a review and then partly new stuff. So a lot of these things we have talked about in class already. This should help reinforce some of the ideas we have been doing. Please don't freak out if you still are like, I have no idea. We are going to walk through this slowly and we're going to continue to practice. This video covers things like atomic number, mass number, isotopes, and ions. So we've talked about the first three, and we're going to spend some time talking about ions as well. Ions are similar to isotopes, but also very much different. So after this video, you should be able to define atomic mass, define mass number, understand how isotopes differ from one another, and be able to distinguish them by various methods, distinguish between mass number and atomic mass, and define an ion. So there's a few things in there. When we have our discussion in class, we are going to be comparing this information to the history on the atomic structure. So how did we go from knowing an isotope is an isotope to Rutherford discovering the nucleus? These are important concepts that we need to make sure we connect. All right, so let's go ahead and start talking about atomic number. My first question to you is, and I want you to sit there and think about it, how does the number of protons in an atom compare to the number of electrons? If you remember anything about what we've been previously learning, you should know about APEMAN, APEMAN, and that should help you answer that question. If you don't know the answer to that question, that's okay. We're going to show some examples in class. But like I said, let's get into the topic of our atomic number. So an atomic number, generally it's represented by a Z, so a capital Z, which is kind of weird, I know, but just go with it. So an atomic number of an element is the number of protons in the nucleus of each atom of that element. So that means the atomic number is a representation of how many protons an element has. An atom has. There is no changing this number. This is the absolute number that identifies an element. So if I say that element has an atomic number of 9, you should always look on your periodic table and say, yep, that is always fluorine. There is no ifs, ands, or buts about that. We don't change the proton number. So very much an indicator. So atomic number always equals proton number. Always indicates the number of protons found in the nucleus of an atom. And this determines the chemical identity. And once you know the chemical identity of something, you can actually start to identify certain chemical traits that it will have and how it will react with other elements on the periodic table. And we're not there yet, but these numbers are really important to determining what's going to react with what is going to sit still. So an atom can be classified as a particular element based solely on its atomic number. And if we are talking about a neutral atom, the neutral atom will equal the number of, the protons will equal the number of electrons. So if it is neutral, like it's not an isotope, it's not, or I shouldn't say isotope, it's not an ion, then it will have the same number of electrons as it does protons. And that gives it that zero charge. Once an atom starts to have a charge, it becomes what's known as an ion. And we're going to get there here in the next couple slides. Mass number. So let's make a connection. What did Rutherford discover and how does that contribute to the mass number? Okay, so think about that. I want you to come into class thinking about that thought. And then I'm going to go ahead and proceed on with the mass number. So mass number, typically indicated by a capital A, is the total number of neutrons and protons present in the nucleus of an atom. There's a big exception to this rule. It is hydrogen. Hydrogen does not have any neutrons, so the only thing that is counted is the one proton that is found in its nucleus. Now, that's not to say that there's isotopes of hydrogen. The isotopes of hydrogen do have neutrons. The neutral form of hydrogen does not. The mass number, like I said, equals the number of protons plus the number of neutrons. I can also say the number or the atomic number plus neutrons. Remember, atomic number equals the number of protons. So those are very much interchangeable. The number, and if you want to rearrange this to actually find the number of neutrons, which typically that's the hardest to find, would be mass number minus atomic number. We've already spent some time talking about isotope notation. So I'm going to go ahead and write that just in case you don't know what I'm talking about. So I have an X, and that represents the chemical symbol. And then we have the A and the Z on the bottom here. So the mass number over the atomic number. This is isotope notation. There is another way to represent isotopes or any atom. In particular, you would just write the name. So I'm just going to go ahead and give you an example. Oxygen, and then I'm going to write -16. That tells me the element, and then it tells me the mass number. Really, really nice way to represent these. You would use the entire element name. Then you would give the mass number. I guess I'm going to leave you with this question on the slide. Can you derive the number of protons, electrons, and neutrons from this information? And we'll do that in class. If you don't think you can, don't worry. We're going to, again, spend some time doing this. All right, so let's go ahead and talk about isotopes. I know we've given a definition. We've talked about it briefly, but let's spend a little bit of time discussing how this happens. So believe it or not all atoms of an element are identical. There are different forms of this atom, and depending on their abundance or how much of them are found in nature determines what's known as the atomic mass. And that's on the next slide. But an isotope is an atom that has the same atomic number but different mass numbers due to a change in the number of neutrons. So the mass number is different because there is an increase or a decrease of neutrons in the nucleus. So there are so many elements that have more than just one type of isotopes. I'm pretty sure it's tin, and I think tin has like 7 forms or something like that. Carbon has 3, hydrogen has 3. I want to say almost all of the atoms that we know about do have an isotope, or yes, an isotope form. And I cannot think of any that do not, but I'm sure there is, and I'll look it up. Anyways, like I said, there are examples of various different isotopes. An example would be like carbon-12, carbon-13, carbon-14. So carbon-12, the mass number is 12. They still have the same number of protons. They each have 6 protons, 6 electrons, but the mass number is different because of the number of neutrons found in the nucleus. The term nuclide refers to the nucleus of a given isotope of an element. So how that nucleus of that isotope looks is what's known as a nuclide. And it's different because it has a different number of neutrons. Neutrons do not determine properties. So just because an isotope exists does not mean it's 100% completely different than the neutral form of the atom. Because electrons are actually more responsible for chemical behavior, isotopes behave just like one another. They have very, very, very similar chemical properties. They react in similar ways, very much identical to one another. Again, the only difference is the number of neutrons found in the nucleus. Atomic mass. This is where people get really a little thrown off because I've already talked about mass number. But remember, mass number is the number of neutrons plus the number of protons. Atomic mass takes that idea just a little bit farther. First of all, the mass of an atom in atomic mass units. So the measurement is AMUs, atomic mass units. And this is in my notes that I wrote. It's not on the slide. AMU is mass exactly equal to 1/12 the mass of one carbon-12 atom. The accepted value of neutrality is carbon, and so anything 1/12 of that would be considered an AMU. Now, why this is different than the mass number. Atomic mass takes into account all isotopes. So let's say carbon, we have 3 forms of carbon, carbon-12, carbon-13, carbon-14, all with different mass numbers. In order to find the atomic mass that you see on the periodic table, you take the average of those and you find the percent abundance of each one of those. We are not going to spend a whole bunch of time trying to find the percent abundance of different isotopes, but just know that all isotope masses are taken into account to give you an average mass that's put on the periodic table. So what you see on the periodic table is the average of all of the isotope forms of that particular element. And last but certainly not least is a new topic known as an ion. An ion is an atom or a group of bonded atoms that has a positive or negative charge. Now, we have not talked about the periodic table. We have not talked about how ions bond together. You may remember that from Science 1 on the change of valence electrons, but it's okay if you don't right now. The main things I want you to understand is that an atom is considered an ion when it gains or loses electrons. So a charge happens due to gaining or losing electrons. We have 2 different types of ions. We have what's known as a cation and an anion. Cations are represented by a plus sign. Anions are represented by a minus sign. And it's kind of weird because it's a little backwards. Cation, you can think of positive. So cats positive. And these lose electrons. Oop, I didn't write that. That was weird. Okay, so they lose electrons. Anions, on the other hand, are represented by a negative, and these gain electrons. And the reason for that is because when you lose electrons, you now have more protons than electrons in the atom. So that's why the positive sign is an indicator there. When you gain electrons, this didn't write there. When you gain electrons, you now have more electrons than, or more negative electrons than you do positive protons. So that's why the anions have a negative sign. I'm going to show you examples of these in class, and there is a pattern on the periodic table where we can identify what is a cation and what is an anion. And I'm going to show you these in class, so please don't freak out if you're like, what is she talking about? Some good examples of cations: Na+, so sodium cation. A good example of an anion is Cl-. And believe it or not, these two have a beautiful relationship. It is known as table salt. We will talk about this in class. If you have any questions, please make sure to ask me on Edpuzzle.